So today we're talking about learning target 5, which is rational exponents. And they're real similar to the radicals that we've been talking about. You can rewrite a radical using exponents. And that's what these first two concepts are talking about. Really, concept number 2 here covers them both, but there's so many that have a x to the 1 or x to the 2 that I kind of broke it up into 2 concepts. But the number 2 concept handles every radical to exponent change. Okay? All right, so rational exponents. Well, we've talked about the word rational a lot. What is the word rational? We had a whole unit on it, the last unit. To us, it's basically fractions. Anything of the form a over b, where a and b are integers. That's the technical definition, but fractions. All right, so concept number 1. You could take the nth root of a equals a to the 1 over n. So you could take a square root or a cube root or a fourth root, and you could rewrite it as an exponent. Example, you could take the square root of 5 and rewrite it according to this definition as 5 to the 1/2. What's the exponent on the 5 in the radicand? 1. What's the index? 2. So that's where this comes in. Same here. Square root of 36 could be rewritten as 36 to the 1/2. And vice versa. Concept number 2. Nth root a to the m. Well, let's take our 5 here that we used, and let's make that instead the square root of 5 to the 3rd. It could be rewritten as 5 to the 3 over 2. Or if the index and the exponent were changed, the example here shows 5 to the 2/3. All right, the first 8 questions are just literally practicing that. Taking a radical, making it into rational exponents, and then vice versa, taking a rational exponent and making it a radical. Okay. The second page of the notes on your copy, the back, is the more like the homework. Okay. So let's do these little practice problems here of using those rules. Square root of 25. Rewrite this as a rational exponent. So that 25 is to the first power, and the index is 2. We would be using concept number 1. 25 to the 1/2. Number 2, cube root of 8 would be 8 to the 1/3. You got it, 8 to the 1/3. Number 3, the fourth root of x cubed. The way I do it is I look at the index 4, and I think, all right, that's the denominator of the fraction. That's the way I have it memorized, because it can be confusing which one do you put where in the fraction. So I personally look at the index and say, all right, that's going to be x to the something over 4. So 3 over 4. And number 4, a to the, again, something over 5. So 2. And then number 5 is kind of tricky, because what's the radicand? What's the base for your exponent? The entire 2x is. The entire 2x is. So when you rewrite it in exponent form, it's 2x to the something over 5. And you need those parentheses. 2x to the 3/5. You could rewrite this using your rules of exponents as 2 to the 3/5 times x to the 3/5. Oh, I'm sorry. Yeah. Because I'm looking at the previous problem and then looking at that 5. It shouldn't be 3/5, sorry. It should be 3/2. Sorry. Fix that to 3/2. On number 2, it's a cube root. So the fraction should be denominator 3. So it would be 8 to the 1/3. Now, we still could write number 5 as 2 to the 3/2 and x to the 3/2. Either of those is fine for now. But that property, the properties of exponents, will allow us to reduce indices down the road. It will also allow us to multiply radicals that have different indices. Whereas in learning target 2, we would have said you can't do that. Okay? Now, backwards. Here's an exponent. Write it as a radical. So Kendrick, number 6. Can you take that one? You got it. Square root of 9 to the 1, so square root of 9. Adam, number 7, can you take that? No? Okay. The memorization technique. Look at your 2/5. You see that 5? That's the index. At least it's the way I memorize it. The 5 in the denominator, that's your exponent. I'm sorry, that's your index. So it's a 5th root. A 5th root of what? Of t squared. And number 8, again, it's just the way I do it. The 4 is the index. So the 4th root of b cubed. All right, 2.5. Well, the first thing is, what fraction is that? Yeah, that's 5 over 2. So this is really y to the 5 over 2. So as a radical, it would have the square root, an index 2. So square root of y to the 5th. And we really would need to simplify these, but for now, all we're practicing is going from exponent to radical form. Okay, so we'll just leave it as square root of y to the 5th. And then the last one, it's a negative exponent, which the very first thing that takes your a to the negative 2/3 and moves it to the denominator. Rules of exponents. A negative exponent moves it to the denominator. And now in radical form, that would be a cube root. The denominator of the fraction, the denominator of your rational exponent is 3. So it would be 1 over a cube root of a to the 2. And so number 10 would be one that we really would need to rationalize the denominator. We're not going to because we're not practicing that today. But we would need to. Okay? Questions so far? All right. On the second page, you only have one page. I kind of broke these up so we'd have more room to write. And the first part, the review here, is just reminding you what we talked about before we started the video on the board. The rules of exponents. When you add them, when you subtract them, when you multiply, etc. Okay? So then we have several examples to try. Number 11. The 36 to the 1/2. Now you can realize, well, that's just what? That's just really the square root of 36, isn't it? So if you wanted to think of it that way, sure. And the answer would be 6. And now, the goal here, by the way, I forgot to say this, the goal is to try to do every single one of these problems without touching the calculator. We might have to on the last two, but we won't until then, okay? That's the goal. 36 to the 1/2. Square root of 36, 6. 125 to the 1/3. That's the cube root of 125. That'd be 5. All right, number 13, as you can see on the board over there, that's why number 13 is labeled 13 on the practice problem before we started. When you have the same base, like you do in 13, 3 to the 1/2 times 3 to the 1/2, it's like having a square root of 3 times the square root of 3. But it's also like having the same the same base, and you're multiplying those same bases. So you add the exponent. So 3 to the 1/2 plus 1/2. No. 3 to the 1/2 plus 1/2 gives you 3 to the 1, or 3. Number 14, similar. You have negative 3 to the 1/3 times negative 3 to the 5/3. You have the same base, so you can add the exponents. And you get negative 3 to the 1/3 plus 5/3 is 6/3, which is negative 3 to the 2nd power. Final answer, 9. You got it. You could choose to go with cube roots if you wanted to, okay? But at this time, I'll kind of just give you the general rule of thumb. If the problem starts as exponents, then your final answer needs to be exponents. If the problem starts as a radical, like our learning targets 1 and 2 and 3 and 4, then your answer needs to end with a radical. Okay? So I'm going to go back to number 11 and 12 just for a second. If those were exponents, we could have done this without ever using radicals. That's 36, which is really 6 squared to the 1/2. And when you have a power to a power, what's the rule? You multiply. So what's 6 squared to the 1/2? It's 2 times 1/2, 6 to the 1. And you can do the same thing on number 12 by rewriting 125 as 5 cubed. Then you have an exponent 3 times 1/3. All right? But I personally, when I do number 11 or 12, I think of square roots and cube roots and finish it that way. All right, but all that was to talk about number 15. It's starting as a rational exponent, so you probably want to finish with a rational exponent. And number 15 on the board over here, we did a warm-up problem for number 15. And what's the rule? When you have same bases, you subtract. So you subtract like bases. So this is x to the 3/4 minus 1/4, which is x to the 2/4, which is, yep, x to the 1/2. And what happened there? You had 4th roots in the original problem, but you had 4th roots. And your final answer is a square root, which means with rational exponents, we can now start looking at different integers, multiplying them, subtracting them, etc. And we'll actually have to adjust our simplest form on the board to also include lowest index. But we'll talk about that more. Okay. It started as exponent, so we're going to finish with exponent, even though we know that's square root of x. Yeah, that's the general rule. If it starts as an exponent problem, rational exponent, then finish with an exponent answer, rational exponent. 8 to the 2/3. I'm fully aware, and I want you to know it's there too, that you can just type that in the calculator, but the goal is to not. The goal is to avoid that, or we'll miss some of those rules that we need to have for exponents with variables. So, personally, I like to change numbers to the radical and see if it'll reduce. So, no? Okay, so we're going to take the 8 to the 2/3 and rewrite it as cube root of 8 squared, which is the cube root of 64. You can do that in your head. And you've done enough cube roots that you recognize that number now, don't you? So that's 4. You can take your calculator and you can hit 8, then the exponent button, the caret button, open a parentheses, 2/3, close the parentheses and hit enter, and it'll say 4. But it also won't do that when you have x squared or variables. So that's why it's important to try these without a calculator. All right, number 17. There was a practice problem on the board for 17. Power to a power, multiply. So x to the 3 times 2/3 is 6/3, which reduces to x squared. 18, 16 to the 1.5. And yes, I know what you're going to do in the homework. You're going to take that calculator. I already heard a few punches. But try to avoid it for now. Okay? What is 1.5 as a fraction? 3/2. So this is 16 to the 3/2. So I'd like to change them to radicals. That's the square root of 16 cubed. I don't know that number. Do you know that number? But do you know what the square root of 16 is? Okay, so what we have is the square root of 16 times 16 times 16, 3 of them. So what we have is 4 times 4 times 4. 4 times 4 times 4. They all reduce. 64. So I want you to practice that. Try that. I know you've got a $100 piece of equipment that can do a lot of work for you. But we're also trying to get efficient with things. And you're more efficient than the calculator if you have all those number competency skills. All right, so then we move on to the next page on the notes here. You got them all on one page. And then number 19 was on the board. There was a problem like number 19 to warm up. And you said on that warm-up problem that you would kind of distribute that exponent. So that's what we'll do. X to the 2/3 times 12 is x to the 24 over 3. And y to the negative 4 raised to the 12th power is multiply those exponents and you get negative 36 over 4. And that becomes x to the 8 over y to the negative 9. And you said on the board that you would take that negative exponent, move to the top. So your final answer would be x to the positive 8 in the top of the bracket, as is y to the positive 9. Final answer. There was a practice problem, a warm-up problem, number 20. And we're sticking with the same theme, simplify first. Is there anything in the parentheses in number 20 that you could do before raising an exponent? Yeah, there is. You can take that x to the negative 1 and move it up to the top. So then it would be x to the 4 times x to the positive 1, which would be x to the 5th. Raised to the 1/3 power. Power to a power. Multiply. So x to the 5/3. Did the problem start as an exponent problem, as a rational exponent? And the general rule of thumb is that's the final answer. We leave it in exponent form. Number 21. Looks a little different, but it's really the same as number 15. It looks different, but it's the same. It's a division, and they're like bases. So what's the rule? Subtract. You got it. Exactly. So a to the 3/5 minus 1/10. Common denominator, you change the 3/5 to 6/10. And then when you combine those fractions, you get a to the 5/10, which is a to the 1/2. Now, do you remember when we did multiplication and division? Didn't we always say you can't multiply radicals if they don't have the same index? Didn't we also say you couldn't divide radicals if they didn't have the same index? Also, the key said for now, right? Because of this. You can multiply or divide different indices, but you probably need to switch it to an exponent form to do that and use your rules of exponents to do it. Okay? Because what this problem started with was a 5th root and a 10th root, and it ended with a square root. Okay? All right, moving on. 22. There's a practice problem on the board for 22, and you squared everything, right? So we're going to take the square root of everything. This will become 16 to the 1/2. 4 to the, or I'm sorry, x to the 4 times a half, so x to the 2 over 25 to the 1/2 times y to the, times y to the 12 times half, y to the 6th. And 16 to the 1/2 is basically square root of 16. So we got 4x squared in the top, and 25 to the 1/2 is basically square root of 25. So over 5y to the 6th. Perfect. You try number 23. It's just like 22, with one difference. It's to the 1/3 power, which means we're going to start thinking cube roots. Is what we're going to start thinking. 1/3 power, thinking kind of like cube roots. Would you put as that exponent on the x?
Squared.
X squared. We went with 6x to the 6 times the 3rd, so 6/3. Yeah, okay. I'll go with that. X squared in the top. What'd you do with that 125 to the 1/3? Thought of it as the cube root of 125 and made 5 out of it? Sure, that'll work. Which then you do the same thing with the 216. And what about the exponent on the y? You did 5, so you were thinking 15 times a 3rd, so 15/3 went with 5x to the 5th. Oops, y to the 5th. You guys won't let me make any mistakes, will you? 6 to the y to the 5th. I'm colorblind, looks the same to me. So. Number 24. All right, you got choices on number 20. Choices. So what do you see first? Oh, that's what you see first? Move the x's and y's? That's what I would think too, because I don't like having those negative exponents around as long as you can get rid of them, try to get rid of them. So that's what I would do too. Right. If they're both negative, if that's x to the negative 2/3, then it will take x to the positive 2/3 to the denominator. And y to the negative 1/3 will take y to the positive 1/3 and move it. So I'm with Tia. That's what I would do. I'd take y to the 1/3, move it to the top, and x to the 2/3, positive 2/3, that is, move it to the bottom. And then power to powers, right? What is y to the 1/3 raised to the 15th? It's a third times 15. 15 thirds. Yep. The final answer in the top is y to the 5th. X to the 2/3 raised to the 15th. 2/3 times 15 is 30 over 3, which is y to the, x to the. Now these last two are the two that I think we might want to lean on the calculator just to do some multiplication. All right? 1024 to the 1.2. You recognize the decimal? Not 3/2 because that would be 1.5. Fifths are 0.2s, 0.4s, 0.6s, so it's going to be a fifth. It's 6/5. 1024 is 6/5. You might just want to type that one in if it were on the test or quiz, but we're going to try to do it without the calculator and see what we can get done. That's a fifth root of 1024 to the 6th power. We have a reference sheet, and it says on that reference sheet that 1024 is a perfect fifth power. What does that reference sheet say is the fifth root of 1024? It says 4. So how many of those fifth roots of 1024 do you have? You have 6, so your answer is 4 to the 6th. So even a little dollar calculator from the dollar store could finish the problem for you if you know those 4 times 4 times 4 times 4 times 4 times 4, which is, I think it's 4,096. And then the very last problem, this is it, number 26, a lot of negatives. There's a lot of negatives, right? If you type it in, I believe you get a decimal. Maybe not. Let's see. All right, first thing that I see a negative on the outside of the parentheses, which just means that's going to take your answer that you get and take the opposite. So don't even think about that negative. Just keep it going in the problem. So it means the opposite of, all right, you see the negative 4/3? You know that that's going to flip something. So it's going to take your negative 7, put it in the bottom. That's now negative 27 to the 4/3 power in the denominator. When you have a negative under a cube root, which is what you're looking at when you have the denominator 3 here on that exponent, can you have a negative in the cube root? Oh yeah, then we're good. We can still keep going. We can keep going. So this would become the opposite of 1 over, I'm going to switch to cube roots. See if we can figure this out. Cube root of negative 27 to the 4th power. Because I bet you can tell me what the cube root of negative 27 is. Yeah, negative 3. How many of them do you have? 4 of them. So this becomes the opposite of a fraction with 1 in the top, and you're telling me that the cube root of negative 27, if I had room, I'd write that as negative 27 times itself, times itself, times itself. That would be negative 3 to the 4th power. Can you do that in your head? Negative 3 to the 4th power in your head? 81. So we get the opposite of 1 over positive 81. There's your answer. Okay. We'll go ahead and